Hello, YouTube. Time for the SAT question of the day. We got a math problem today. In a class of 80 seniors, there are 3 boys for every 5 girls. In the junior class, there are 3 boys for every 2 girls. If the two classes combined have an equal number of boys and girls, how many students are in the junior class? Whoa, a lot of dense information in the problem. So there's 2 ways to do it. One way is to do it algebraically, basically solve directly for the answer. The other way, which I think is the better way, is to actually just use the answer choices and instead of trying to do the problem, pick an answer choices, test them out, see which one works, and go from there. So I'm going to do it that way first, and then I'll do it the algebraic way second. So let's figure out the first part. So it's a class of 80 seniors. There are 3 boys for every 5 girls. So I like using this thing called the ratio box. I took it from the Princeton Review. It's just a really useful way to organize your information on these kind of ratio problems. So boys, girls. So it's a 3-to-5 ratio. So we add this up. The total is 8. Now there's actually 80 seniors. So 8 times what is 80? Well, it's 8 times 10, which means these must be 10. So 30 times 50. So I look in the ratios video. I believe in the ratios video of the boot camp, I talk about ratio box if you're confused about what I did here. But basically, it just lets me know the breakdown. So I have, in this case, where there's 80 seniors, 30 boys and 50 girls. Now, I eventually want to have, when I add in this junior class, an equal number of boys and girls. So let's keep that in mind. So what I'm going to do now is test the answer choices. So I'm going to look at, say, 84. And I'm going to say, okay, how many boys and how many girls would there be? Well, 84 is a problem because I've got 3 boys for every 2 girls. So I go ahead and create a quick box here. So 3 to 2, add those up, it's 5 boys and girls. Now the total is 84. No integer will multiply by 5 to get me 84, right? 5 doesn't go into 84. In other words, if you're doing it the fractional way, 3/5 are boys, 2/5 are girls. There's no number times 84 that's not going to be an integer, right? I mean, that's going to be an integer. This is some fraction, some decimal. So 84 is off the top. Same thing with A. A is not going to be divisible by 5, so we can get rid of that. So let's test, why not? Let's test B. So let's do a table. 3, 2, 5. So it's 80. 5 times 16 is 80. So we put 16 over here. So we have 48 and 32. Will that make it even? Well, here, basically I need a difference of 20 between them, right? Because I've got a difference of 20 here, so I need 20 more boys than girls here, which I don't have. So B is gone. How about D? Well, let's see. 3, 2, 5, 100. So this is 20, 20, 20. Here we go. So I've got 60 boys and 40 girls, which means I've got 20 more boys than girls. And again, I could add these up. So 60 plus 30 is 90. 40 plus 50 is 90, so I'm equal. So the answer here is D. And with the testing the answers method, you do not have to test all choices because unless you've made a mistake, you know that the only answer is going to be D here. 120 is not going to work. So D is the answer. That's the plug in the answer way. Basically, you say, okay, if this were the answer, what would the consequences be? So does it actually work as an answer if the ratio is 3 to 2? Would that lead to an equal number of boys and girls? So that's the plug-in way. I think it's the best way for this problem. But if you want to do it algebraically, what do we do then? Well, notice again, there are 80 seniors with a 3-to-5 ratio. In this case, as we figured out, it already turns out to be a 30-to-50 ratio of boys to girls. So we need to figure out what the ratio will need to be in order to get, we have the ratio. We need to figure out how many juniors we need. So we need X juniors at a 3 to 2 ratio. That will get me more boys than girls, 20 more boys than girls, so that will even it out. So basically, I need to figure out, well, I know that this number of students is going to be 3/5 X, right? Because there's 5 total parts, and this is 3/5 of those parts. And this will be 2/5 X. And then I want to know, basically I want this to be 20 bigger than this. So I want to know, when does 3/5 X equal 2/5 X plus 20? Right, that will indicate to me that this is 20 bigger than this. So I will do the math here. So I get 1/5 X equals 20. Multiply both sides by 5, I get X is 100, which is what I had as an answer before. So not super hard when you actually know how to do it the algebraic way, but the setup is a bit challenging. So I think for the SAT, for the purpose of the SAT, plugging in the answers or testing the answer choices works much better than doing it directly, just because you kind of makes sense to have to work through these numbers and see which one actually fits. Okay, that's it for this question.